In this example, we're going to move beyond the idea of a square root and talk about other roots, such as a third root, a fourth root, a fifth root, or an nth root. But to build up to that, we're going to begin with the idea of a square root again. In part A, if the square root of 49 is 7, what is the third root of 8, and why? So let's begin with the square root of 49 being 7. We know, because 7 times 7 equals 49, that the square root of 49 is 7. The idea of a third root is very similar. When we use third, it is a reference to the third power, meaning the third root of 8 is a number that I would multiply by itself 3 times to get 8. So a similar statement would be, because a number times itself equals 8, then the third root of 8 is that number. Now before we get into what the third root of 8 is, please do notice the radical notation. A third root uses very similar notation to a square root, and it will use similar notation to any other root. The way we identify the root is by what we call the index. The index is the little number sitting in what I call the foot of the radical. That index essentially tells you what reverse exponent you're working with. Because that is a third root, it means I'm going to be looking for something raised to the third power, or something multiplied by itself 3 times. Getting back to the answer to this question, I know that 2 times 2 is 4, and 4 times 2 is 8. So 2 times 2 times 2 equals 8. Because 2 multiplied by itself 3 times is 8, then it tells me the third root of 8 is 2. So when we talk about a third root, it is looking at the third power in reverse. Instead of raising the number to the third power, we're saying what number, if raised to the third power, would give us this value. So in part B, the question is, what is the third root of 27? We would write the third root of 27 as a radical with a 27 underneath the radical and a 3 as the index. And so the question is, what multiplied by itself 3 times would give us 27? 3 times 3 is 9, and 9 times 3 is 27. So the third root of 27 is 3. In part C, what is the fourth root of 81? The fourth root of 81, again, is asking what number multiplied by itself 4 times would give us 81. We would write that as the fourth root of 81. And building off of our answer from part B, 27 times 3 is 81. I know that it took 3 3s to make 27, and adding one more 3 into the mix, or multiplying by one more 3, gives us 81. So the fourth root of 81 is 3. Again, the reason being, 3 to the fourth power is 81. And similarly, for part B, the reason that the third root of 27 is 3 is because 3 to the third power is 27. In part D, we want to rewrite the third root of 125 is 5 in mathematical notation. So again, because we are dealing with a root, we will use the radical notation. Because we are taking root of 125, that means 125 is under the radical. Because we are talking about the third root, we need to write the 3 as the index in the foot of the radical. And the third root of 125 is 5. So this third root of 125 equals 5. Again, the third root of 125 is 5 because 5 to the third power is 125. In part E, we want to rewrite the fourth root of 16 is 2. So again, we begin with a radical because we're dealing with a root. We're taking the root of 16, so 16 is under the radical. We want the fourth root, so we need to have an index of 4. And because this value is 2, we need to say that it equals 2. And so that's how you mathematically write the fourth root of 16 is 2. So in part F, we want to come up with a formal definition of what we mean by the nth root. So this would apply whether we're dealing with a second, third, fourth, or 100th root. Given a number x, if there is some other number r that when we multiply r by itself n times and we get x, then we say that r is an nth root of x. it is important to recognize that there could be more than one nth root of x. And so that's why we're saying r is an nth root of x, not the nth root of x. Again, in radical notation, the way we would say the nth root of x is that we would use a radical, we would have x underneath the radical, and the index would be n. And based on our statement above, the nth root of x equals r, because r to the nth power equals x.